In this video, we're going to continue our conversation on NeoPixels and rehash a little bit of what we talked about for for loops. So this was the program that we had on our Arduino the last time in the last video, where it was going through and it was starting at the beginning of the strand right here and going all the way through the end and choosing a random color to set all the way down. So let's pull up that program, and that's what we're going to use as our starting point this go around. So we had all of this set up here where we included the library, set the pin that it was connected to, declared the number of LEDs that were connected to it, and then set up our strip. But we also created these global variables here to represent which pixel number we were talking about, and then hold the red, green, and blue values that we wanted to set. Inside of setup, we're always going to have these steps here where we begin the strip, show the strip, and set the brightness of the strip. And then right now inside of our loop, what's happening is every time the loop function executes, it's going to set the color for 1 pixel. So it starts at 0 as declared by this, and then it goes on down the line every time we add 1 to its value, so it continues to increase and go down. And then once number of pixel equals strip.numpixels, which is 30, meaning that we've reached the end, what it does is it sets it back to 0 and then randomly generates 3 new values for it to set. And so that's why it changes its value once it reaches the end. So it's this purple, it's this yellowish color, and then it just keeps kind of changing. And you know, in person, there's a lot more subtleties and nuance and beauty in the colors. Everything just kind of shows up a little bit washed out on the webcam. But what we want to do is we want to look at how we can leverage our knowledge of for loops to control the color of the NeoPixels a little bit better with the for loop, as opposed to just setting one per per loop execution here, because the for loop is going to allow us a lot more fine-tuned control and help us do some more animations that we're going to play around with in the future. So let's look at how we can adapt this here. All right, and so the first thing we're going to do is we're actually going to get rid of all these global variables. We created these global variables because we wanted to keep track of which pixel we were talking about across various loop iterations, but now what we're going to do is inside of the loop function, we're going to have a for loop that's going to run through each of the individual ones, so we don't need this anymore. All right, so I'm going to get rid of this part, and actually we can just kind of get rid of everything. Let's start with a clean slate inside of our loop. So what we want to do is we want to set up a for loop to iterate over each one of the different pixels there. And so we're choosing a for loop because there are a finite number of pixels that we want to visit, so that's why we're using a count controlled for loop that executes some expected number of times. And so we need to declare the 3 parts of it, kind of the initialization, the condition of the for loop, and then how it's going to update between executions. So what I'll do is I'll declare some variable I, and I'm going to set it equal to 0, because the first pixel in our strand is always going to be 0, and the last one is going to be the total number of pixels minus 1. So it's going to go from 0 to 29, and so my condition here should be while I is less than the strip.numpixels, which is just going to return to me the 30 that I set up here. And so what we're saying is continue while I is less than 30. Once it goes beyond, or once it equals 30 or goes beyond 30, stop the loop. And then what we'll do is we're going to add our update, which says how we want to update that variable I between each loop execution. So we're going to add 1 to it. So it's going to go 0, 1, 2, 3, all the way up to 29. Then once it gets to 30, this loop will stop, and then it would go on to the rest of the program, which there's nothing else, so it would go back up to loop and run over and over again. All right, so that's kind of the basics of setting up that for loop there. There are some other things that we'll need to do, right? And so what we need to do is strip.setPixelColor, right? And so this is the thing that's going to take 4 values. There's going to be some the first value is going to be what number pixel we want to set, so that's represented by our variable I, and then we're going to need to set a green, or a red, a green, and then a blue value here, okay? And then I'll put my semicolon here. But we got rid of those variables that have the red, green, and blue. And so what we'll need to do is create them, but now what we're going to do is we're going to create them locally inside of here. So I'll say int r equals random 0 to 256. So this is going to randomly generate a value between 0 and 255 because it's inclusive of the first value and exclusive of the last value. And I'm going to repeat this for the green and the blue. So now we've declared these three values, and we've declared I, which tells it what pixel we want to set. But if you remember, setting the pixel color doesn't actually make it show up on the strand. There is another step that is called strip.show, and that makes it actually reflect the changes visibly. And then if we wanted it to have a little bit of a delay between it starting and going down the line, because otherwise it would just go all at once, what we'll need to do is add a delay inside of this for loop. So it's going to start at 0, update the pixel color, show it, wait 50 milliseconds, go on to the next one, and keep going down the line until it reaches the end, and then it's done. So once it reaches the end, it goes back up to the top of the for loop, or to the loop function, and it regenerates three new values. So this should essentially do the exact same thing that our other program did. We've just now adapted it to maybe be a little bit more coherent and cohesive using this for loop here. So let's make sure it behaves the same way we would expect it to. All right, so let's pull up the camera here. And yeah, it's looking like it's working all right. I'm gonna try to, there we go. So yeah, it's changing colors on down the line here, just like we would expect. It's essentially doing the exact same thing. So let's play around with this for loop a little bit more, just to make sure that we understand kind of what's going on here. So what if instead of doing them one at a time, it kind of did it all at once? So what that would look like is we would need to move these two statements outside of the for loop. So it's still updating each pixel inside of the for loop, but now what's going to happen is it's not going to show it until after the for loop is done executing, and then we're going to have a little bit of a delay. I'm going to try to lengthen this delay a little bit, maybe make it 2 seconds, so that we can see it before it changes, because 50 milliseconds is a pretty tight window. So it's updating, there we see it flash, so now the new program's on there. So now it's going between different colors for 2 seconds, where it's kind of looks like it's updating it all at once, but we know it's going down the line. It's just not showing it until we get to that point. So there's one example. I'm going to back this up a little bit, and let's see. Instead of, let's think about this. So instead of having it set all of them to be the same color, what if we wanted it to set each pixel to be a different color? What I could do is, instead of using these variables R, G, and B that we defined up outside of the loop, what I could do is I could replace R, G, and B with a new call to random, so that each time it's randomly generating a new value. And we could take a look at what that looks like. So since we're not using those, I'm going to comment those out right now and upload this new sketch. And there it goes. So now we see that they're all different colors. It's randomly generating a different red, green, and blue value for each one of those pixels. And we can see how that impacts it. Let's see, what else would we want to do? Let's maybe, so right now it's going from the start of the strand to the end of the strand. Let's try to make it go in the reverse direction, from the end to the start. And so what that's going to do, what that's going to require is just a modification of this for loop. Nothing inside of it, just a modification of this to make our I start at the end and go down to the beginning. So to make it start at the end, we need to make it start at the strip.number of pixels, which returns 30, but I said the last one is 29 because our numbering starts at 0 as opposed to 1. So what I'm going to do is say start I at a value of strip.number of pixels minus 1, which is always going to make it start at the very last pixel. And then what we need to do is we can't say repeat while I is less than that, because it will kind of continue to be less than that. What I need to do is say repeat while I is greater than or equal to 0. And then instead of going in steps of +1, what we'll do is go in steps of -1. So I will say I minus minus instead. All right, so that should work to make it go from the end to the beginning. And so it's uploading, and now we see here it's going from the end and spiraling back to the beginning where there's this termination where the wires go into the Arduino. So that's how you could kind of set an animation to go from one direction to the other direction. And those are some good examples of how to use a for loop to control this. And this is going to lead very well into our next video, where we're going to talk about how to bake these for loops into functions so that we can have dedicated functions that perform different animations on our NeoPixels that we could use anywhere in our project or across a variety of different projects.